what is mechanics and what we are going to study in mechanics. So mechanics is the physical science which deals with the effect of forces. Force and the effect of forces. When a force is applied on a structure, that can create a moment, a bending or rotation. So force and these moments, we are going to learn two things here, forces and moments. So as I have mentioned, I have discussed before, so for any engineering design, there are many forces applied on a structure. So, and also force can do many things. There are different kinds. We give names to forces. This we call the compressive force. This one we call a tension. This we call a bending. This is a torsion, and this is shearing. So we need to know these different types of forces and how they will affect the structure. So that's what we are going to learn here. Okay, so if you divide the mechanics, we can divide them into mechanics of rigid bodies, mechanics of deformable bodies, and also mechanics of fluids. So fluid mechanics is for fluids, which we have liquids and gases, and mechanics of, so in our section, we are talking about solids. So both of these ones, mechanics of materials and also fundamentals of mechanics, in both of these subjects, we deal with solids. The difference is in our part, in fundamentals of mechanics, we discuss about the rigid bodies. Rigid bodies means when forces are applied on anything, on a structure, we consider the structure won't deform. So they are rigid, but in real case, they deform. But we need to idealize the situation to go to the next step. So we assume the structure is rigid. So when we learn how to apply the theory for a rigid body, we will be able to extend that to a deformable body later on. So that's what we are going to do. So we do look at the structures which are stationary, and also we are looking at the structures which are moving. So we do both of these structures. And in the fluid mechanics, again, if you do it, we divide it into compressible and incompressible. It's like deformable and non-deformable. Compressible means you can compress it. Gases are compressible. Liquids, again, we assume they are incompressible when we learn fluid mechanics. So then we have another branch. Extended version of the fluid mechanics is hydraulics. So you have an elective subject, hydraulics, as well, I think, in this course, if you are selecting later on. Fluid mechanics, again, civil engineering, mechanical, chemical, they all do fluid, because you are dealing with the fluids, gases, and liquids, maybe petrols, the pipes, or any lubricants that you use in machineries. So you all learning about mechanics. Fluid mechanics is an important subject in those areas. Let's talk about vectors. So what is a vector? Vector has two things. It should have a magnitude and a direction. Because they have a direction, when we are dealing with vectors, we need to pay attention to the direction. For example, if you have, maybe you have 5 apples and 2 apples in 2 bags. If I ask you to add them, and if I ask, well, how many apples totally you have, you will say maybe 5, 6, 7 apples, isn't it? So, but if I say you have, one person is pulling you to one side with 5 newtons and another person is pulling you to the same side with 2 newtons. If I ask you how much of force acting on it totally, what will be your answer? Then again, you can say 7 newtons. But in case if this person is pulling you into the other side, then can you still say the total force acting on you is 7 newtons? Can you say that?
Because there's no direction defined as of yet.
Yes, so you can't say that because this direction matters. 5 is towards the right and 2 is towards the left. So you can't just add the numbers, add the magnitudes together. When you consider a scalar just have a magnitude. You can add the numbers together. You can minus the numbers together, numbers by one number or by another number. But when you consider vectors, when you are adding and subtracting, when you are multiplying, when you divide, we need to pay attention to the direction. So we have methods developed to add them, subtract, or else multiply or divide. So we are going to learn these methods. Okay, so we all know what is a vector, which has a magnitude and a direction. So we can represent vectors by graphically and also by words. So when you are representing a vector by graphically, this is how you represent. So it has a starting point and it has an ending point with an arrow. So the arrow represents the direction. And the length of this line, it represents the magnitude. So this is how we graphically represent the vector. So starting point, we call it the tail. Ending point, we call it the head. So tail, starting at tail and ending at head. And the magnitude is given by the distance or the length of the line, and the direction is given by the arrow. And we can represent them using words as well. So there are two ways that we can represent a vector using words. That one method is referring the xy axes. For example, if I say this is 30 degrees from the x-axis, I can write it as 5 newtons from 30 degrees from x to y. Or else I can say 5 newtons 30 degrees in the counterclockwise direction from the positive x-axis. Or else I can say 5 newtons 60 degrees in the clockwise direction from the positive y-axis. Do you agree with me? Can I say the same? Are they all mean the same? Positive x-axis, 30 degrees in the counterclockwise direction. So from the positive y-axis in the clockwise direction, 60 degrees. So that gives us the direction, and this gives us the magnitude. So that is referring the xy coordinates. Again, we can refer the north, west, south. So this compass. So if you say that, if you use that, you can write in the same way. So you can say 5 newtons from east to north, 30 degrees. So this is our east, this is our north, so east to north. So you can also write it 5 newtons east to north 30. This is the shorter version of the same thing. East to north, we write east at the front and the N at the back to mention that east to north. Can one of you tell me another way of writing the same thing, referring north to east? If I write from north to east, how should I write it?
5 newtons north 30 E.
Yes, 5 Newton north to east, 60 east. So you can write in this way as well. In some questions, you will get the graphical representation. In some questions, they will explain the vector or the force by this word by word. So you should be able to identify, you should be able to imagine this graphical representation when it is given by words. And why the vector? What is I told you at the very beginning, we are going to deal with forces. But why we are learning vectors now?
Is it because of the forces acting onto the material?
With a
a vector.
direction,
Yeah,
yes.
with a direction.
Force
Yeah.
is a vector. So force is a vector. So when we are dealing with force, that means we are dealing with vectors. So that's why we are learning about vectors, because force is a vector. And also I told we are talking about the moment. Moment is like, it's a rotation. So if you apply a force like this, that if you have a clamp here, this one make a moment, it can rotate. So that moment also has a direction. It can rotate in the clockwise direction or counterclockwise direction. So moment again, a vector. So that's why we are learning about vectors. Because later on, we are going to talk about forces and moments. So we need to know how to deal with vectors. Okay, so I already told you. So when we add vectors, we can we can say this 20 and 15, we can add them together and we can say it is 35. Why we need to know how to add them, subtract them? So if you look at this one, you can say there are many forces acting on this structure. We have live loads, we have dead loads, we have wind loads, snow loads, that load, this load, many loads. So we should be able to, when there are many loads applied on, many forces applied on a structure, we should be able to find the net force. To find the net force, depending on the direction, we need to add forces together. So we need to learn how to add forces together. So this one is a simple one, which is 20 plus 15, which is 35. But if you have something like this, how can we add it? Can we still say 35? We can't, because the direction matters. So how do we add them?
On the angles.
Yes, you need to now think about the angles. So we have methods to add vectors. So we have a graphical method, and also there are analytical method. So when we look at the graphical method, there is one method called parallelogram law, and there is another one called triangle method. And when you look at analytical method, you have two methods again, component, and also you can, I'll come back to this one later for the analytical method. So let's look at the parallelogram method. So in this one, what you do is you draw the vectors from tail to head. So like this. So you can start with either V1 or V2. So they both are vectors. This bar here represents that it is a vector. So you start at a point and you draw this vector. So you know this angle, the direction is known thing. So you draw this vector in the graphical method, we draw them. So when so you represent the magnitude of the V1 by the length. Then at the point where are you now, then you draw the next vector. So next vector may be making alpha degrees from the horizontal axis. So that will be like this, and it is longer. Maybe we represent the length by that one. So this is your end. What you do is you make a parallelogram with this one. And the parallelogram in this one, start to end, this will give you the resultant. So net force or the total of, if you add V1 and V2, that will represent by this diagonal length and the direction. This is the same as the triangle method. You are making a triangle. In the parallelogram, actually, you are making it like this, and you make a parallelogram and take the diagonal as your result. So both are very similar. You make a triangle or you make a parallelogram, and you find the direction and the magnitude using that diagonal length and the direction. Okay, so it's like this. In the triangle method, as I have mentioned, so you draw them like this, or else you can either start with V1 or V2. Here we have started with V2, and you have to have this alpha angle here, then you are stopping at this point, then you draw V1, and the start to end will give you the start to end will give you the resultant. So you can either start with V1 or V2. It doesn't matter. It should give you, you should get the same answer. So that we call the triangle method. Okay, so we are making triangles. So when we make triangles, we can draw them to the scale using protectors and rulers. However, if you can use the trigonometric relationship, you don't have to draw them to the scale. You can use the trigonometric relationship to find this length and the direction. So these trigonometric relationships, I hope you remember. For a right angle triangle, you can use Pythagoras theorem, and also you can use this relationship sine, cos, and tan. So we are going to use them for right angle triangles. And also for any triangle, you can use sine rule and cosine rule. Are you guys familiar with the sine rule and the cosine rule? If not, tell me, I will go through again. So for sine rule, it's like this. So let's take, you have angles as A, B, C, capital letters. And also if you have lengths, in front of A, you have A length. In front of B, you have B length. And in front of C, you have C length. So the relationship between these angles and the lengths shows us the sine rule. Sine rule says sine A over A length is equal to sine B over B is equal to sine C over C. So if you know few of the angles or few of the lengths, you can use this relationship and find the unknown angles and the unknown lengths. You can swap this and you can make it upside down, and you can use this way as well. Both are correct. So that means the sine rule. In the cosine, any question? Are you okay with the sine rule? I hope you hear me.
We can hear you.
Okay, so in the cosine rule, what the relationship is, if you don't know, like, if you don't know one length, for example, let's say you don't know this one. But if you know these two lengths and the angle between these two lengths are known, the blue things are known, you need to find the red one. So you can write a relationship. A squared is equals to B squared plus C squared. B squared is one known length, C squared is the other known length, and then you minus 2 times A times C, sorry, B times C times B, C are known, cos A. So this we call the cosine rule. So if you know two lengths and the angle between the two lengths, you can write an expression to the unknown length like this. So that we call the cosine rule, and we are going to use that rule. Okay, are we good? Now let's see how we can do this. We quickly can do this one. How do we add these two together? So I can say, I'm going to draw the triangle now, okay? 10 to the north, 8 to the east. So start to end will give me the resultant, which is this one. So it's making a right angle triangle with a 90-degree here. So I can use the Pythagoras theorem to find the R. So R is equals to R squared. So I can write R squared is equals to 8 squared plus 10 squared, and R is equals to 8 squared plus 10 squared square root of this. So I can find the magnitude if they are in newtons, the magnitude is in newtons as well. Am I right? So if you want to find the angle, our answer also should have magnitude and also the direction. So we can find the angle, which is this one. So we can say it is from north to east, theta angle. So how do we find this angle? You can use the sine, cos, tan relationships. If you write tan theta, opposite over the adjacent, 8 over 10. So you can find theta, which is tan inverse 8 over 10. So you can write your answer, this many newtons from north to east, this many degrees. So you can write it in that way. So is that clear? Any question?
Got none.
Okay, so we can say, you need to now write the answer correctly. So you can write it. Resultant is 12.8 units north to east, 38.66 degrees. So that's how we give the answer. Now, I hope it is clear. Now let's see these two. They have given us V1 is 10 newtons and V2 is 8 newtons. Now we are going to draw this. So I'm going to draw. So we can draw with, you can either start with V1 or V2, it doesn't matter. So I'm going to start with V2, which is 8 newtons. So it is making 15 degrees like this. So this is my start. Now I am here. So from this point, I'm going to draw 10 newtons, which is my V1. It should make 30 degrees. So this is 30 degrees and it is going 10 newtons. 10 newtons here. So this is my end. Start to end gives me the resultant. So this is my start to end. Now we don't have right angle triangle. So we need to use sine cos tan. We can find the, if we know this two lengths and the angle between the two lengths, we can write an expression to the resultant unknown length from the cosine rule. Do you remember that? So we can write the unknown length if we know two lengths and the angle between the two lengths. We know the two lengths because one is 8 newtons and the other one is 10 newtons. Do we know the angle between the two lengths? Can we find it?
Yeah.
Yes, because this is 15, isn't it? This is 15, this is 15 as well. And this one is 30. So 180 minus 30 plus 15 will give you the angle, the internal angle, isn't it?
Yep.
So you can find R. Can you find me the R? So we can write it as 15 squared plus 10 squared minus 2 times 10 times 15 cos whatever the angle you have. So I hope you remember the expression. So R squared is equals to 1 length squared, the other length squared minus 2 times the two lengths multiply and cos the angle between the two lengths.
Isn't it meant to be 10 squared plus 8 squared?
Yes. My error. Right. Yes. So what do we get? Angle is 45. 135, isn't it? So if you find R, you need to take the square root of whatever the answer you get. And what do you get?
I got 16.6. I might have done something wrong.
How about others?
Yeah, I got the same.
Okay. Now we are okay with the magnitude. I hope all are okay with that. Now we need to find the angle or the direction. So let's see, I'm deleting this one, but I have everything in a nice way. Okay. Okay, so we have this. Now to find the direction. So if you want to find the direction, you need to always try to find the direction at the start point. So this is your start. So find this angle. Otherwise, you need to think and redo. It's okay to find this one here, but it's making another one. You have to do one more step again if you use that. So you just always use the angle at the start. Find the angle at the start. So let's find this angle. I'm just taking this as theta. How we can find it? We can't use sine cos tan relationship for a right angle triangle, but you can use the sine rule. So sine rule says what?
Sine A over A equals sine B over B equals sine C over C.
That's right. So if you write the sine theta over the opposite length, which is 10, is equals to, you have, another angle, which is this one. So sine 135 over the opposite length, which is R. You already found R, 16.64. So you can find sine theta. So sine theta is equals to 10 times sine 135 divided by 16.64. So you can find theta as a sine inverse of this. Can you please find me the angle theta?
$25.1.
So theta is equal to 21 point.
25.1.
Okay. Yes, 25.1. Okay, now how do we write it using xy? So they have given us xy. So how do we write it using xy in words? How can we write it? Magnitude is this, it is straightforward. But this 25.14, is it from x to y, y to x? Now think and tell me, from where to where? If I write the xy coordinates here, that's this one. So theta is that whole angle.
Is it from X?
From x in the counterclockwise direction, you can say from the positive x in the counterclockwise direction, but it should be this purple part only, but you have found this big part. So how can you find this purple part only?
Take away the 15.
What's that?
Take away the 15.
Yes, that's right. So you need to take away 15 because that angle is 15. So you minus a 15 degrees here, then you can find the counterclockwise angle from the positive x-axis. So that will be 10.14, isn't it? Sorry, 5.14. Sorry, 10.1.
Right, 10.14.
10.14, yes. So you can write it like this. So you can write it 16.64 newtons, 10.14 degrees, counterclockwise from the positive x-axis. So that will be your answer. So you should write the answer in the right way. Otherwise, we will lose some marks for the final answer. When you do these questions, do it step by step and show your working out. Even though your final answer is wrong, you will get the marks for the steps. So, and also if you have any errors carrying out, if you have done this one wrong, and you don't mark down for the full answers, like that error carried out will be considered, and according to whatever you got here, we are marking the rest of the things. So please show your working out whenever you are doing any exams or anything. Okay, I think now you guys are okay with the graphical method. So if I give you a few minutes, don't do this one. We need a bit of time to do that. Can you tell me, can you try this? A car is pulled by two ropes. If the resultant force exerted by FA and FB is 25, the resultant is given, R is given to you, 25 kilonewtons. X-axis, determine the FA and FB, knowing that theta is 60. So this one is 60. Okay, I will give you some time for you to think. Think and try. Do we know the direction of, we know the magnitude of your resultant. Do we know the direction of the resultant?
No, is that what we're trying to find?
No, we are trying to find FA and FB. We don't know these two forces.
Oh, okay, so we're working backwards, righto.
Yes, you are working backward. And do we know the resultant force direction? Car should be pulled to where?
X.
X direction. That's right. So we know the direction of the resultant because we want to move the car forward. So we know the direction of this one as well. So you draw the triangle with whatever the things that you know. You can either start with FA or FB in a way that your resultant is in the X direction. Start to end is X direction. If you find, let me know. If you can't, just try. Yeah, we are going to do together. Okay, so if you can't, don't worry. If you don't understand, let me know. So let's. It's okay to start from by A or FB, okay? It doesn't matter. So FB, if I start from FB, it is making 60 degrees with the x-axis. So this is 60, this one is 60, this is 60, so it is 60. So this is my start. Now I am here, I can draw the next one, which is FA. It is making 20 degrees from the x-axis. So start to end will give me the resultant, which is exactly horizontal or in the X direction. So this is how I draw. Did you guys draw something like that? If you want to, you can draw like this as well, okay? FA with the 20 degrees and FB with the 60 degrees. So this is your FB and this is your FA, and start to end will give you the resultant. So both the triangles are right, just the mirror image of the other. So both are right. So did you draw something like this? Anyone have any issues with drawing the vector diagram, vector triangle? This diagram we call the vector diagram. So it should have directions and lengths correctly put. Are you all okay with the vector diagram? So what we know now, so this angle is 60, this is 60 as well. So this is 20. So if this is, you know the three angles, am I right? The three angles, you know, if this is 67, 680, then this should be 100. Because the three angles, when you add them together, it should be 180. Now, what rule can you apply? Sine rule or cosine rule, which one is better here?
Sine rule, but for sides.
Yes. So you can write FA over the opposite angle, which is sine 60 is equals to 25, 25 sine opposite angle, which is sine 100 is equals to FB divided by opposite angle, which is sine 20. So now you can find the FB and FA. If you consider these two together, you can find FA. And if you consider these two together, you can find FB. So is that right?
Yeah.
Okay, so can you find me these two? Is there anyone who don't understand up to here? If you want me to go through again the same thing, I can do that.
I have answers for you.
So do I. Hey, we're both smart.
No, we're not. No. We're not. Yeah, we're doing okay.
I think I hear you very. I need to. Sorry. You see my screen again, right? Okay. So what do you get for FA and FB?
Does someone else want to have a go?
Okay.
I've got my answers. I just want to.
Okay. Yes,
Yeah.
yes. Is anyone want to tell the answers?
Yeah, I've got mine, but someone else can go in. Also, I got FA of 21.98.
Same.
That's right.
And yeah, 8.68. Yeah, cool.
Yeah.
Yep. Same.
Good.
Sweet. I think everyone else is having a snooze.
Are we all good? Anyone got any other answers? We can go through because first week you may feel like it is very simple, but if you get this one, the rest will be easier because we are going to apply the same thing, but for complex situations. But if you know the basics, you can apply it correctly. So are we all good? Anyone need further clarification? So we are not going to do this one for the time being. Okay, we can come back to this one later on after you. It's bit different. Okay, so let's do that one later. Okay, would you like to try this? Now they say resultant force is 0. And find the F. what do we mean by resultant force is zero? How should be the triangle now? How should be the vector diagram now? So we find the resultant by drawing a line from start to end. If the resultant is zero, what will happen to your start and end?
All on one of the axes?
So if start to end is end, what it say resultant is resultant is zero means it says your start to end is zero, isn't it? There is no distance between start and end. That means your start and the end is the same point. Am I right? Do you agree with me?
I do.
Yeah, it should form a
Okay.
closed shape when we finish.
Yes. So can you now draw the triangle in a way that it will be start? Triangle, I mention it as a triangle because you have three forces. If you have 100 forces, again, you draw this and that, all the hundreds, and your start and end should be the same. Here, you only have 3, so you make a triangle. So can you draw the triangle? You can start either from 8, 14, or F, it doesn't matter which one you start with. So I can draw 8, it is just horizontal like this. Then I can draw maybe 14. 14 is making 30 degrees like this. And F should be coming, starting from the end of 14 and coming back to this one. So this is how I drew it. So you can have shuffled these forces, that doesn't matter, but you still have a similar kind of a triangle. Do you guys have the similar kind of a triangle?
Yep.
Okay, now do we need to, we need to find F, and also we need to find theta. To find F, if we know two lengths and the angle between two lengths, we should be able to find F. Do we know two lengths and the angle between the two lengths?
Yep. Cosine rule.
Yes, you apply the cosine rule and you find the F. So it says F squared is equals to 14 squared plus 8 squared minus 14 times 8 times 2 times cos 30, because 30 is the angle between 40 and 8. So you can find the F. What do you get?
8.12.
Yes, that's right.
Hmm.
Close. Maybe I'm wrong. 8 point something. No, so that's right. Now to find theta, what can we write? Can write the sine rule. Sine theta divided by the opposite length, which is 14, is equals to sine 30 divided by the opposite length, which is f, 8 point whatever the number you got. So you can make the theta the subject and take the sine inverse of this one, and you can find the theta. So what do you get as the theta?
Uh, 59.
Let me check. Yes, 59. How we can write it in words now? So 59 is right. Do we all get 59 and 18, 8 point something? Is there anyone?
The last one. I got the first one was right. 18. I got 8.12.
Okay, that's fine. How about the theta? Are you okay with this equation? You get 59 now?
Yep, 59.5.
Okay.
Yep.
Anyone else got 59, or if you got something else, we can do it again.
No, I got the same. Yep.
Okay, that's good. Now I told you once, it's easier if we find the angle at the start of the resultant. So start of the resultant is this one. We always mention the angle at the start. So we found this one as 59. So we need to find the angle at the start. So if this is 59, this also should be 59, isn't it? Is that right? So this angle also should be 59 degrees. So how we can write the answer now? From where to where? Just use x, y, z. So if you use x, y, z now, your x, y, z 0 origin should be the start point. So this is your y and this is your x. So this 59 is from negative x-axis in the counterclockwise direction. Do you agree with me? 59 degrees in the counterclockwise direction from negative x-axis. Agree with this?
Yep.
Yeah, so we need to write it
Yep.
the proper way, otherwise we can go wrong. So always mention the angle at the start. So that's why we went to the start, and you draw the xy axis as or north, south, east, west compass directions at the start point of the resultant, not at the end point of the resultant. Okay, so that's good. So we found that answer as well. Okay, so we are now we are confident with this when we have 3 forces. But if you have more forces, what will happen? You can follow the same method, but you draw from start to end, head to tail, all of these ones. You draw, and this will be your start, and this will be your end. And from start to end again, you get the resultant. That theory doesn't change, but that theory is true for any number of forces. But if you use this triangle method, if you use this graphical method for when you have many forces, we are ended up with the polygon with different different number of sizes. So we may need to divide it into triangles, and we need to apply the sine rule and the cosine rule many times. So is it easy? It's not practical, isn't it? So when you have many forces, we are not going to follow the graphical method. However, in your practicals, you have only 3 forces, so you are going to use the graphical method. You are drawing in a graph sheet. You are finding the answers during the intensive session. Now let's see the analytical method. So when we have more forces, analytical method is much easier. So in the analytical method, what we do is, we call the component method. We divide the force into components, X direction and Y direction. So, okay, so when we have a vector like this, we can, X component is the projection in the X towards the X, and the Y component is the projection towards the Y. So if you want to find the Vx, that we call the X component of the vector, if you can find the Vy, which is the projection in the Y direction, we call that the Y component of the vector. So how can we find it? So let's take this. This is making a right angle triangle. So if you write the sine theta, you know this angle and the magnitude, okay? So theta is known, V is known. Those two are known. We need to find the components now. So if you write the sine theta, you can write it as opposite over V. Am I right? So we can write Vy as V sine theta. So the Y component is found just by writing the sine theta. Similarly, can you find me the Vx, X component?
Use
If you're,
Pythagoras theorem to find it as well. For the X.
you can write the cos, isn't it easier? Cos adjacent. If you write the adjacent, if you write the cos theta, that will be adjacent over V. So Vx will be your V cos theta. Am I right? Agree with that? Now let's see, is when you add these two, X component and Y component, is it giving the resultant? Is this 2? So without having V as a one vector, having Vx and Vy, is it giving us the same vector, same thing? Is it representing the same vector? Yes or no? And if you say yes, I want to know why. And if you say no, again, I want to know why you say no. How you guarantee that Vx, instead of writing V as a one vector, we can write it as Vx and Vy. Adding these two vectors will give us the V. How we can prove it? So in the previous one, we said if we have two vectors, just ignore this now. We have Vx and Vy. If we want to add them together, we draw them start to end, and we find the resultant from start to end. So if this is my start, I go Vx along the X direction, Vy along the Y direction, and this is my end. So the resultant of this X, so Vy plus Vx, or the X component plus the Y component, that will be our resultant. So that will be the V, isn't it? So we can either write V as a one vector, or else we can represent V as two components, which is V sine theta plus V cos theta. Do you agree with that? Anyone who is not agreeing with this? Is it clear or not?
Yep.
Okay, so we can divide a vector into two perpendicular components by sine and cos. You don't have to write the sine and cos all the time. There is an easy way to remember it. X component, or else always when you are going towards the known side, this will be your cos. So this one will be your V cos theta, if the other side will be V sine theta. For example, if I say this, I want you to tell me which one is cos and which one is sine. So you can write it like this, right? So you can reach it like this. So this will be your y component and this will be your x component. Tell me which one is cos, which one is sine. Y component, can you tell me what is y component?
Y
If you-
components sine, X components cosine.
Okay, are you sure? Now write the cos theta. If you write the cos theta, this is your x component, this is your y component. Okay, if you write cos theta, do you write it as y divided by v, or else do you write it as x divided by v? Adjacent, isn't it? Adjacent divided by the hypotenuse. So your x is v cos theta. Agree? Sorry. This is y and x. I put in the wrong direction. This is your y and this is your x. Sorry. So this is your y and this is your x. So if you write the cos, how do you write the cos? Cos is adjacent. Adjacent is the y here, isn't it? Y-axis is the adjacent. Y-axis is the vertical axis. So y divided by v. So your y will be v cos theta. Agree? If you write
Yes.
sine theta, what's that?
Just
It,
agreeing.
it will be x divided by v, so x will be v sine theta. So by looking at this, can you always say, this is some a place where everyone, most of the students going wrong. So can you always say y-axis, y component is sine? Can you always say that?
Depends on the direction.
You can't. You have to look at the direction. Can you say all the time x component is cos? You can't. So what is the easy method that I told you to remember? When it is going towards the known side, this is the known side. Known side is cos. Known side is cos. Is that clear? Is it easy to remember? Known side is always cos. Opposite side is sine. Okay, let's do some questions and see whether you remember that. Okay, can you divide these two components, both the vectors? So we have 10 newtons. This is the same question. We are going to use the component method to find the resultant for this one, okay? So you have these two vectors. I want you to find the two components of this. Okay, let's start with the 10. 10, you can reach the 10 like this. So what is the x component? It's going towards the known side. So this will be sine or cos.
Cos.
Other one is sine 30. Okay, now anyone have any question regarding this? How about the 8? So 8 can be start to end, it is going like this. Am I right?
Yep.
So x component is what?
Sine.
Are you sure? You are going towards the known side. For the x side, x-axis, you are in the known angle side. Known angle is with the x-axis. So it is
Values. Okay.
other one is sine. Now, any question up to here? X is always measured this side positive and Y measured upward positive. So can you tell me, is this component 10 cos 30, is it positive or negative? Is it towards the positive x direction or negative x direction? Look at the arrow.
Positive.
Positive. How about the y component of 10 sine 30?
Positive.
Positive. How about the 8 cos 15?
Positive.
Positive, because the arrow is towards the positive x side. How about the y component 8 sine 15?
Negative.
Negative. So now you can find the resultant by adding the components together. So to find the resultant x component of the resultant, you add these together. So both are positive, so you can add them and you can find the x component of the resultant. Then you can add the y components together. One is positive, one is negative, and you can find the y component of the resultant. So can you please find me these two?
Uh, 16.38 and 2.92.
How about others? Do you get the same numbers? Let me check what I got. I got this. Yes, you said the same numbers, right? 15.94 and 4.9.
I got 16.38 on the first one.
My one is wrong, maybe. Yes.
I think it's because I did directly with the cos 30 and the cos 15. I didn't take the rounded numbers.
Yes. I rounded.
Oh, I did the same, yes.
Yes, that's fine. So we get 16 something and 3 something here.
I got 2.93.
2.93 and 16.38. Your
Yeah.
V2 for cos 8 cos 15 is supposed to be 7.73.
Okay, now we found the x component and the y component of the resultant. We can't have it as two forces. Now we need to find the resultant force. How can we use the x component and the y component and find the result?
Add them together.
You add them together. How do you add them?
You use Pythagoras' theorem.
You can use this, you can draw it to scale, or else you can just draw a triangle. You get a right angle triangle this time, isn't it?
Yeah, so Pythagoras will work.
Yes, so you add them. So you have 16 point, 3, I think, in the x direction, which is 16.3, and in the y direction, you have positive. Both are positive. That means this direction and this direction. So this is your start, and you have 2.93. Start to end will give you the resultant. So you can find the resultant force and the direction theta using the trigonometric relationship. You can use tan theta to find the angle and Pythagoras theorem to find the r. We should get the same answer we got with the previous method if we have done everything right. What we get.
My answer differed slightly on the hypotenuse.
Which one is different?
The R, only slightly, but again, that's rounded answers that I've used.
R is my one is wrong because I have 15. It's yes, it can be because rounding of things.
Yeah, I got 16.639.
That's okay. That's fine. So theta is 10.4. I think it's again very close. So we can write the answer in the same way. R is 16 newtons, 10.4 degrees, counterclockwise direction from the positive x-axis. So you draw x, y, z like this, and from the positive x-axis it is 10.4 degrees. So this is just two vectors. When you have maybe 10, 8, 7 vectors, you still can follow the same thing. One by one, you divide them into x component and y component. You algebraically add the x components together and y components together to find out the resultant x component and y components. So I hope you are okay with that now. So can I give you a few minutes for you to do this one? Not that one. It's easy. I have only that, I think, yes. So we have more questions in the tutorial. We'll do more questions. So can you please do this one by yourself? I'll give you a few minutes, then I do after you try by yourself.
Yeah, I'll give it a go.
Okay, so you can carry on your work. Okay, so I'm just x component, y component, and we can say we have 12 Newton force and a 7 Newton force. So we can write cos and sine, don't get it confused. So 55 is with the x-axis. So with the x-axis, so it is cos. So 12 cos 55, and this one will be 12 sine 55. You do your work, okay? I'm just going through if someone need help. Otherwise, you are good to go by yourself. And 7 will be 7 again, cos is with the x-axis. So 7 cos 32, and this will be 7 sine 32. Now the sign convention. So this one is going like this. So x is negative, y is negative as well. But the other one, 12, it's going like this. So y is positive, x is negative. So you check your signs. Signs are important. And the cos and the sine also important. Positive, negative important, and also cosine important. Now you can add them and you can find the result. Anyone have any question up to here? I hope you are okay with the cos, and you have to practice. When you practice, it's hard to go wrong. So you need to do a few more questions to get familiarized with this cos sine, which side is cos, which side is sine, and also to familiarize with these positives and negatives. But you have a lot of questions in the tutorial. We are going to do that. And you can try by yourself as well if you want to. Any question, guys? Did you get the same?
Yeah, so far it's the same for
Yes.
me.
That's good. Now let's see what I have. I got this. I'm not sure whether I am right. Did you get like this?
That's what I got.
Okay, so how can we draw the result, find the resultant now? X component is negative, so it should go, this 12.82 should go towards the negative x. It is negative, so this negative represents the direction of x. You have a positive here, so it is going like 6.12 is upward. Now you can draw. You can either start with x or y, it doesn't matter. So I'm going to start with y. So this is my start. I'm going 6.12 positive y direction, and then I'm going 12.82 in the negative direction. Start to end will give me the result, which is this. So you can use the Pythagoras theorem and you can find the resultant R and also the theta angle at the start. So R is equals to 6.12 squared plus 12.82 squared, square root of this one. And theta is tan theta, you can write as 12.82 divided by 6.1. So you can find the resultant magnitude and also the direction. Do we get this?
Yep, I got the same.
Okay, that's good. Okay, so that will cover most of the things that we have. There is a one more small part, which is Cartesian representation of vectors. It doesn't take much time, so we'll go through that as well. So in the Cartesian, this is important when we do the 3 dimensions especially, because then we are defining x, y, z directions. So in the Cartesian, coordinates. So if someone say a point coordinate of a point as 2 and a 3, you know 2 is the x coordinate and 3 is the y coordinate. That means along the x direction you have to go 2 units, along the y axis you have to go 3 units. So that's how we represent the coordinates. Now, if you give unit vectors means it has a direction, but its magnitude is 1. So we define the unit vector for the x direction as y and the unit vector in the y direction as j. When you have z, that will have another unit vector. So we can write the vector OA. So again, to make represent it as a vector, we draw this line and an arrow at the top of OA. O means the start is at O and finishing at A. So as it is a vector, we draw this line and the arrow. So you can write this as 2 times 2 units along the x direction plus 3 units along the y direction. So this we call the Cartesian representation of the vector. Is that clear? Any question?
No, makes sense.
Okay. Now, what is this number in front of the I? That is the number. That number represents the x component. Do you agree? And the number in front of the j represent y component. Am I right?
Yep.
So if you don't know coordinates, if you know the magnitude and the direction of a vector, 30 degrees and 10 newtons, will you be able to represent this vector as a Cartesian vector? Can we do that? Yes, we can. How we can do it? We can write this as 10 times, so this x component times I plus y component times j. So what is the x component in this case? It is 10 cos 30. Y component is 10 sine 30. So haven't we written it? So we have converted this magnitude and the direction to a Cartesian form. Do you agree with that?
Yeah.
Okay. In case if these two were given to you, if these two Cartesian form is given to you, will you be able to find the magnitude and the direction? Can you go back and do that? Do you know how to do it? How do we find the magnitude? So you know this is 3 and this is 2 and this is 3. So the magnitude will be what? 2 squared plus 3 squared, square root of that, isn't it? It's the same thing that we did in the previous question, isn't it?
Yeah, Pythagoras theorem.
That's right. And also if you want to find this angle theta, how do you do that? That tan theta is equals to y component divided by the x component. Am I right?
Yeah.
So when the magnitude and the direction is given, you can convert that vector to Cartesian form. And if the Cartesian form is given to you, you can convert it to the magnitude and direction. Are you okay with that?
Yep, that makes sense.
Let's see whether you are okay with that. Okay, so this is the same question that you just did. Now, can you convert this into convert these ones into Cartesian form? How do you write the V1 as a Cartesian vector? How do you write that? If you want to write V1, how do you write it as Cartesian form?
8.66i.
Okay.
Is it plus or I can't remember if it's plus or minus.
If it is, so you have it here. So your V1 is this. So it went like this.
Oh, yep. So plus 5j.
Yes. How about V2? It's going like this.
7.28i minus 2.07j.
Okay. Now, if you don't know this, if you want to find the Cartesian form of the resultant, what you do? You can add the x component, whatever you have in front of I together, and you will get this 15.94 I for the resultant. And when you add this separately, y components, maybe y components together, you will find the y component of the result. Because you have a negative, you need to algebraically add them. So when the Cartesian vectors are given, you can add the x components together and y components together in the same way. And you can find the Cartesian form of the resultant force without doing any of these ones. You can find it. This is important for us when we do 3 dimensions. Okay, so when you have another one, you just add that z component separately. Are we good? Any question?
No, I'm all right.
So